Okay, so the last video cut off my writing, but I did finish explaining. When I use the slope formula, this is the property that I'm proving. Both pairs of opposite sides are parallel. So that with slope, that's all we can prove. Are parallel lines, perpendicular lines, or neither. Okay, it tells me nothing about the distance or the measure of those sides. But look at our next question. Now, same figure, we want to find the distance of each side. If I'm using the distance formula, distance is the length, right? The measure of the sides. So the property that would go with that is if both pairs of opposite sides are congruent. So when I use my distance formula, that is the property that I'm proving. Both pairs of opposite sides are congruent. Okay, so this one's going to be a little bit of work. We are going to use the distance formula to prove that these two pairs of opposite sides are congruent or not. So let's take AD and BC. Okay, this is my first set. This is my second set, right? It's the same picture. In order to use distance formula, I need to know the coordinate points. Okay, so if I plot A, here's my origin. A is at 1, 2, 3. 1, 2, 3. So I'm going to write that next to A, 3, 3. D is right here at just 1, 0. Okay, remember that's your x value, your y value, x value, y value. Your distance formula. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. I need to take my x values, the difference of my x values, and square it, plus the difference of my y values and square it. Remember, you can also do Pythagorean theorem. Okay, that goes back to slope, but we'll just do the distance formula because it says so. So if I do the distance of AD, I need to take x2, we'll just call this x2, 3, minus x1, 1. So 3 minus 1 squared plus y2, 3, minus y1, 0 squared. So I'm not going to do this step by step every single time, but that is just plugging it in. Okay, so 3 minus 1 is 2, and 2 squared is 4. 3 minus 0 is 3, and 3 squared is 9. So the distance of AD is the square root of 13. Okay, so if I did the distance of BC, because that is the side that's opposite to it, B has a coordinate of 8, 2, and C has a coordinate of 6, negative 1. So same concept. x2, 8 minus x1, 8 minus 6, that would be 2 squared, plus y2, 2, minus y1. So 2 minus negative 1. Remember, 2 minus negative 1 becomes 2 plus 1, or 3 squared. So 2 squared is 4, 3 squared is 9. I get the square root of 13. So these are congruent because they both come out to be the same thing, the square root of 13. Then I would do the same thing for AB and DC. So now I'm going to show you just on a graph the shortcut that you can do besides doing the distance formula. But on a test or a quiz, right, we do want to see the distance formula if it tells you distance formula. But here's a way that I can prove on a graph using my slopes. Okay, remember on a graph, if I just take from A to B and I drop down a rise and I drop down or form a run, right, I'm creating this right triangle. I can find the distance of this diagonal line using Pythagorean theorem. This has a side of 1, this has a side of 5, which I got that from my slopes, right? Remember, length of side is always positive, so I don't need the negative. But if I did Pythagorean theorem, I would take 1 squared plus 5 squared to get that distance squared. Or 1 plus 25, and then take the square root, it'd be the square root of 26. Okay? Same thing over here. If I did a vertical and a horizontal, that would create another right triangle that has a sides of 1 and then 1, 2, 3, 4, 5. it would still be 1 squared plus 5 squared, which equals a square root of 26. So these also have the same distances, meaning that they're parallel. So yes, both pairs of opposite sides are congruent. Okay, and again, we would use the distance formula to prove that specific property. So a lot of work, it looks a little messy, but that is how you would solve number 9, using the distance formula for both pairs of opposite sides. Okay, last question, number 10. So when I use the midpoint formula, okay, the midpoint formula to determine if something is a parallelogram. All right, so let's look at just our figure. If I plot this, f is at -2, +4. So here's my origin, -2, +4. G is at 4, 2. This was F, G, H is at 4, -2, so that's right here. And J is at -2, -1. Okay, we never assume based off of a picture if something is a parallelogram or if something is any kind of quadrilateral that we're studying. We have to prove it, okay? So, midpoint formula. Let's talk about midpoint, right? A midpoint, from what we learned in chapter 1, cut a figure into 2 congruent parts. Okay, cut a figure or a segment into 2 congruent parts, a midpoint. So if I go back and I look at, let's just look at these pictures. Are any of these pictures, does any of these seem like there's a midpoint somewhere? Well, this kind of looks similar, right? Here's a line cut into 2 equal parts, and so here's another line cut into 2 equal parts. Meaning, this property, the diagonals bisect each other. If that occurs, then that means that this point of intersection is a midpoint for both diagonals. If it's getting bisected, it's getting cut in half. So this point of intersection of my diagonals would be the midpoint for each diagonal. Okay? So that would be the property that I would have to prove using the midpoint formula. Okay, that diagonals bisect each other. Okay, so I would need to know, okay, my diagonals, right? My diagonals, if I drew them, would be FH and JG. Those are my 2 diagonals. We cannot just look on our graph and be like, oh, there's our midpoint, and, you know, put some random coordinate. Okay, I have to figure out, do they share the same midpoint? Okay, remember on this picture, that was the same point for both, right? If that was on a graph, let me try to make it so you can see it. If that's on a graph, that is one coordinate point, and each diagonal has that coordinate point. So in order to prove this, the midpoint for each diagonal has to be the same. So let's start with FH. The midpoint is when I take my x values, here's F, -2, and H, 4, and I add them together, divide by 2. Those are my x values. Then I do the same for my y values, 4 and -2 divided by 2. So my midpoint for FH, -2 plus 4 is 2, divided by 2 is 1. 4 minus 2 is 2, divided by 2 is 1. So the midpoint of FH would be 1, 1, which is right there. Okay, I can already tell that this is not going to be a parallelogram, but let's just do the midpoint of JG. Okay, if I take the x values of J and G, I have -2 plus 4. Okay, so far that looks okay. That would have the same x value of 1, right? -2 plus 4 is 2, divided by 2 is 1. But let's look at the y values. J is -1 plus G, 2, divided by 2. -1 plus 2 is going to be 1, divided by 2 would be 1/2, which is why you see this point over here. Okay, so 1 1/2 is not the same midpoint as 1 1. So this was not a parallelogram. All right, but you need to know why you would use slope, distance, or midpoint formula to prove which property. Okay, that is important.